which is question number 56. Let's read it. Paints are colloidal solution of solid in liquid. Here solid is the dispersed phase and liquid is the dispersion medium. That means the correct answer is option number 1. Moving to the next question, which is question number 57. Let's read it. The time required to produce 0.2 mole of H2 using a current of 2 ampere by the electrolysis of aqueous sodium chloride is. Students, since we have to calculate the time to produce H2, that means we have to consider the reaction that occurs at cathode since H2 is liberated at cathode. So I'm writing the reaction that occurs at cathode, which is equals to 2H2O plus 2 electron gives H2 plus 2OH minus. So here it is very clear that 2 mole of electrons are required to form 1 mole of H2 gas. That means to produce 0.2 mole of H2, 0.4 mole of electrons must be required. Now we can calculate time, since we know that charge is equals to I into time. I is current here. Charge is equals to 0.4 multiplied by Faraday's constant, which is 96500. The value of I is already given, which is 2 ampere, and we have to calculate time. So student, time is equals to 19300 seconds. Let's convert this into minutes. It will be 321.66 minutes. Student, I have multiplied and divided the entire terms. You please avoid using calculator. Try to solve all these questions with your hands only, so that your speed will be increased eventually till your NEET exam. So here it is very clear that the correct answer is option number 3. Moving to the next question, which is question number 58. The equilibrium constant for the reaction 3SN4 plus 2Cr gives 3SN2 plus 2Cr3 plus at 298 Kelvin will be. Student, we all know that E cell is equals to E naught cell minus 0.0591 upon N log Q. At equilibrium, we know that E cell will be 0. So 0 is equals to E naught cell minus 0.0591 upon N log K. Now student, we can calculate the value of K. So log K is equals to N E naught cell upon 0.0591, which is equals to, I'm putting the values, since the value of N for the reaction is 6 multiplied by 0.9, since we are given with the value of E naught cell, upon 0.0591, which is equals to 91.37. Student, again I'm telling you that I have already multiplied and divided the equation. You please don't use calculator or avoid using calculator. So it is very clear. So student, now I'm writing on the right hand side, log K is equals to 91.37. That means K is equals to 10 raised to the power 91.37. So the correct answer for this question is option number 4. Moving to the next question, students, which is question number 59. Let's read it. The electrode potential for Cu2 plus to Cu plus electrode and Cu2 plus to Cu solid electrode are plus 0.15 volt and plus 0.33 volt respectively. The electrode potential for the electrode Cu plus to Cu will be. Student, first of all, for this question, we need to know that E naught cell is not an additive property. Rather, delta G naught is an additive property. So first of all, we have to calculate delta G naught for the given cell reactions, for the given cell, and then we'll be able to calculate E naught cell for the required reaction. So here I'm writing the first reaction, Cu2 plus to Cu plus. So Cu2 plus aqueous, gain 1 electron to convert into Cu plus aqueous. Here the value of delta G naught, I'm marking it as 1, is equals to, here I'm writing the formula to calculate delta G naught, which is equals to minus NF E naught cell. So here the value of N is 1. Let's take F as F only, and the value of E naught cell here is 0.15. Now student, I'm taking the next reaction. Cu2 plus aqueous will gain 2 electrons to convert into Cu solid, and I'm marking the delta G naught for this reaction as delta G naught 2. The value of N is 2. I'm taking F as F only, and the value of E naught cell is 0.33. Now student, here I'm writing the required reaction, that is the third reaction. So Cu plus aqueous will gain 1 electron to convert into Cu solid, and the value of delta G naught, I'm marking it as 3, is equals to minus 1 into F into E naught cell, and we have to calculate this E naught cell. Students, it is very clear that delta G naught 3 is equals to delta G naught 2 minus delta G naught 1. Let's put the values. Minus F into E naught cell, which we have to calculate, is equals to minus 2 into F into 0.33 minus minus plus 0.15 F. Student, using this equation we can calculate the E naught cell for the required reaction. So E naught cell here for the required reaction will be 0.51 volt. That means the correct answer is option number 4. Moving to the next question, students, which is question number 60. Let's read it. Standard oxidation potential of the half reactions are given below. We have to identify the strongest reducing agent among the following. Student, you need to keep in mind that in general, in such questions, we are given with the reduction potentials. But in this question, we are given with the oxidation potentials. And if oxidation potential is given, you need to keep in mind that more is the oxidation potential, stronger is the reducing power. So among the given options, the strongest reducing agent is Mn, since its oxidation potential is maximum. So the correct answer is option number 2. Moving to the next question, students.